Welcome back to this topic on deploying models. So we'll be continuing on AI inferencing. So just a quick recap of what was actually talked about in the previous video. In the overall AI pipeline in production, the AI inferencing is actually the last section when we make use of the model that's actually created, and we use that to make predictions about new data. So when we query this, the new prediction is actually generated for the end user. So we'll be talking about this section of the overall pipeline uh, shortly. So AI inferencing, which is that last section. So first of all, AI inference is actually the process, or AI prediction is actually the process of taking that model, deploying it onto a device, which will then process incoming data. Usually it could be images or video, or just a normal structured data, and to look for and also to identify whatever needs to it has been trained to recognize. So basically, it makes use of the new data to make predictions. So the AI inferencing part is actually the lower part here. So when is the trained model that's been created by the training pipeline earlier, when we pass it new data or new samples, the model will then make a prediction about what's the output or what's the correct label that's associated with that new input. So if your new input is actually a picture of a cat, and you have been training this model with examples of images of cats and dogs, so when the picture of a cat is presented to the model, it correctly infers that the correct label for that input image is actually a cat. So that's the essence. So we are actually talking about this part, the prediction portion of the AI pipeline. Now, this slide talks actually about the training process. The process of using a framework for training and inference actually are pretty similar, but during training, a known data set is actually passed through the untrained neural network or machine learning algorithm, and the result is actually the model, right? So these labels are passed to it as well as part of the training data. The framework results is then compared with known data results, dataset results, which is the label, and then the framework re-evaluates the error and then back propagates this data through the neural network to actually update the weights, and then the weights basically represent the correct set of values to be used within the algorithm itself. This re-evaluation is important to training as it adjusts the neural network weights to improve the performance and to the task that is actually trying to learn. So you can see from this diagram that during training, the training data is passed through the untrained neural network, is compared against the actual labels, and then the error is propagated back through the neural network and is used to adjust the weights so that the error is reduced on the next iteration. So this is basically an optimization algorithm that actually adjusts the weights, and then the neural network is trained in this process. Now, a similar process can also be applied to other training algorithms, even if you are not using a neural network, but the training process is very much the same. You have a set of input values or features that you present to the model. The algorithm will then learn from this input data and then compare against the labels. And by comparing against the labels, it can update the algorithm so that the prediction will be gradually improved, and then the model will actually be generated from the patterns that's learned from the association, or the rules linking the input and output is learned by the algorithm, by the learning algorithm, and then the model for that is actually generated. Whether it is the algorithm is a neural network or it's, some other algorithm like a support vector machine, the process is by and large similar. As compared with, so the output of this is actually the model that's generated from the update that we uh, the updates to the weights or the model parameters as we actually iterate through the many training examples. Now, during the inference process, so the procedure that we talked about just now is actually the training algorithm, and this training pipeline can actually be deployed using the AI infrastructure that we talked about earlier. So it could be a container or a virtual machine that actually contains this entire training pipeline, and actually passing the data through the training pipeline, we actually generate the trained model, and this trained model is then passed over to the inference or the AI prediction process, which may be in a separate container or pipeline. So unlike training, inference doesn't re-evaluate the weights of the neural network. It just makes use of the frozen weights, right? Whatever has been trained in already, it doesn't do retraining again. It just takes the weights from the trained model, and inference applies that knowledge that's in the model and uses it to predict or infer the result. So when a new unknown data is actually presented to the trained model, it will make a prediction, and it outputs the prediction based on the model that's in the neural network, and this would have a certain accuracy. Inference comes after training, as it requires the trained neural network model or trained model to actually work with. So inference process doesn't do the training again. It just makes use of the available model from the training process and passes live or new data to it so that it will make a prediction. So it's only the forward process or the prediction step or the inference step is executed. There's no backward step or training step that's executed by the inferencing pipeline. So we're going to take a look at some other views of this. So in this slide, actually what we are talking about is that the training pipeline as well as the inference pipeline, which we talked about earlier, but a different view of this. So in this slide, we are talking about how you as a programmer would actually manually create the pipeline. So this is not an automated process, it's being maintained manually by the developer. So in that pipeline, which may be running as say within a container or within a virtual machine, we will actually present to it data that we have collected earlier. So since this data has been collected earlier, it is not live, right? It is actually what we consider offline data. So this pre-collected data or stored data is we will do some data cleaning. So we will extract the necessary features from it, as well as also do some data exploratory data analysis to better understand the data. So once these key features have been extracted from the data and we have done appropriate data transformation to it, we may then still do some further cleaning of the data, for example, filling in missing values and removing outliers before we actually present the data to the algorithm to do the model training. And once we've done the training, we would then evaluate the result to see how good the model that we created is. We can do cross-validation to make sure that the model is not overfitted and the hyperparameters are tuned correctly. So this whole thing is done within this training pipeline, all the way from data preparation to model training to finally model evaluation and validation. And finally, the output is the trained model, which we are going to store away into our model registry or our container registry so that we can actually use it later on for inferencing. So this part here is actually the more machine learning training portion of it, whereas the more operational or inferencing side is everything that is on the right hand side. After the model has been trained and stored, we can pull this model out from the model registry, and we can then or the model store, and then we can use it with new data and then serve out the predictions, what we call AI inferencing or model serving. So we will talk in more detail about this as we go along, but this is actually the process that we can use to create the model manually. You can see that actually you have to run each of these steps by hand, right? You have to do it step by step, maybe in the Jupyter notebook, but you got to run it part by part, or you can automate it to some extent if you write the code, and then but you still need to execute your Python scripts one by one to actually run through the entire pipeline. And if you need to make any adjustments, you basically need to rerun some of these steps again until you get the output train model that's of the quality that you want, and gives you evaluation results that are suited to what the criteria that you have set aside uh, to determine whether or not this model is good enough for deployment. So if it's not good enough, of course, you have to go back to the drawing board, either collect more data or improve the feature engineering so that you can retrain the model to the quality that you need. So in this rather busy slide, we actually have the automated version of that machine learning pipeline that we described earlier. So this pipeline is maintained automatically, so you can see some feedback loops where previously you had to do things manually. Now actually there's some automation that does this automatically for you. So for example, the update of the code within the training pipeline is done from the code repository. So our feature extraction is taken from the feature store, and we are going to use that feature extraction process from the feature store to determine what's the feature extraction that we will actually get from the data itself. Right. So once the data has been extracted, we will then do data validation, we will do preparation, the usual stuff, do the training, and then do the model evaluation and model validation. So this part is done automatically within the pipeline, and the update of this pipeline is also done automatically. So this is the difference between this and the previous pipeline where we have to execute each of the steps manually, but here we use automation tools, for example MLflow, to just run all of this automatically within our container. So the other part of it, the update of the modeling code itself, is also done by this other loop here, where after doing the data analysis, we have a number of experiments to optimize the machine learning code. So any new code that's generated is stored into the code repository, and this code repository will then be used to update the training steps taken automatically. Now, this training pipeline, we can actually store some of the metadata, for example, hyperparameters that we use, or the number of training samples that we need, or the number of bootstrapping examples that we want. All this additional information about the process itself is what we call the metadata, and we can have a separate metadata store for all of this. So hyperparameters actually very difficult to replicate because it takes time and effort, and also a lot of computational resource to replicate the best hyperparameters. So oftentimes this is probably the intellectual property that you should protect carefully, because even if somebody knows the algorithm, they may not be able to reproduce your results unless they also have the hyperparameters or metadata. Now the AI inferencing part, which is actually just this end here, and we're going to explode this and talk more detail later on in this series of slides. But this AI inferencing part is also automated. So now the trained model that's actually obtained from the training pipeline is stored in the model registry, and the model registry can then be used to feed into the model serving portion. Okay, so in the previous example, we stopped here at the model serving, which gives you the predictions. But one more step needed. We need to close the loop. How do we know that our model is continuing to give us the kind of predictions that are as accurate as we need it? So model drift and data drift is a perpetual problem in machine learning implementations. So this model monitoring is a very key part of a production system. When we want to put it into production, we need to monitor the results to make sure that the predictions that we are still getting when we compare it against the original data is still aligned with what we are expecting. So if the output starts to drift away from the origin, so originally maybe we are getting 90% accuracy, But with time, we actually detect that our accuracy is dropping below 90%, it's going to 80%. So there is some drift in the data or in the model. So when we monitor the model, we realize that actually the accuracy is no longer what we need it to be, then this will trigger a retraining process. So we get new data in, or we improve the feature extraction so that we can improve the model and train the model such that it will again give us back the kind of accuracy that we need. So this is what the model monitoring part does. So you can see that in this automated machine learning pipeline, there are a lot of loops. Okay, so instead of a step-by-step process, now there are actually loops with feedback so that it can continually improve with time. And we can actually automate this so that actually you don't need a human to run each of these steps by hand. Right, it can be on a schedule so that it will just monitor, and then once there's some deviation that's triggered by the monitoring, we can just rerun the loop again with new extraction. Of course, when there's exception, a human will normally come in and then fine-tune the loop that we have currently, the training loop that we have. And the development also require, when we want to add new code, of course, this still requires a human being to evaluate the results of the different experiments and then pick and adjust the code so that it will actually give you the best result. So with this, we come to the end of this slide. So thank you for your attention, and I will see you in the next set of slides.